So I'm going to talk about Hadoop, thing that I've been working on most recently, and which has been the subject of a lot of press, a lot of attention. I think a lot of people are rightly concerned that there could be some hype around Hadoop, that it's maybe a little overblown. I'm going to try to describe both what Hadoop is, as well as the trends that are driving it and the trends that it's following, and hope to convince you that there's actually something here that I think is a solid foundation, that it's a platform that will be around and that will make you comfortable in adopting it, or at least informed in doing so. So first, talking a bit about where Hadoop came from. There are these, I think, long-term trends that it's really the result of. It was the right thing at the right time. It was sort of fortunate. On one hand, we've got Moore's law and these hardware trends that have been delivering faster processors, more memory, bigger drives, expansion across all these dimensions for 20, 30, 40 years, a very long time, which is phenomenal. If you step back and think about it, I can think of no other technological trends that have seen that kind of exponential growth sustained for that length of time. And so it's not surprising that you sort of see some phase transitions now and then in the way these technologies are used. As this has become more affordable, the hardware, and more powerful, we've seen it spread across industries. And it's used in businesses you wouldn't have imagined that it was used in a few years ago. Like every tractor these days has a GPS and is recording its position as it goes around. People are putting sensors out in fields, measuring the sort of microclimates. It goes on. There's technology everywhere, and it's even become, I think, a primary driver of economic growth. The sectors of industry that are growing the fastest are the ones that are adopting technologies the fastest. You've got these trends of businesses using lots of technology, which means that they're generating lots of data. Now, a lot of it may not be being saved today. It might be just flowing through, but it's possible to save it. And it's affordable to save it, given that processors and drives are so cheap, and it's affordable to analyze it. This sort of confluence of conditions was what Hadoop was born into. It was originally to support a particular application, web search, but people have found it useful in many other ways. So I got started down this road trying to build a system called Nutch. We were trying to reproduce approximately what Google does or what Microsoft does with being a web search engine, but entirely as open source. I'd previously had experience in open source through Lucene and liked very much working in that methodology and thought that web search would be a good thing to do there. And we right away needed to have distributed technology because the web was bigger than we could store or process on one computer. And we spent a couple of years, and we had something that was kind of up and stumbling along. And we saw some papers from Google describing the way they were doing things. Google published a paper first about GFS, the Google file system, then a paper about their MapReduce processing framework building on top of GFS. And these were just obviously the right tools for us to be using in Nutch. We were doing almost the exact same sorts of computations that you would do in MapReduce, and including the shuffle and all the phases of it. We weren't calling it that, and it wasn't automated. It was very manual. And so it was easy to, well, it wasn't totally easy, but it was easy to imagine moving all of these things on top of a MapReduce engine. So we set about doing that. It was another fellow and I, Mike Caffarella. Took us a couple years, and we had something that now, instead of being able to run with a lot of manual intervention on maybe 5 machines, we could run something on 20 or 40 machines. But that was as many as we had access to. I was working at the Internet Archive, and Mike was working at University of Washington. And at that point, Yahoo came along and said that their architecture for distributed data computing that they were using in their web search needed a rework, and they thought this work we were doing in Nutch looked really appropriate. And they had thousands of computers and could really make sure that it scaled and performed well at scale. So I went to work for Yahoo for a few years, and they put a large team of developers on it. And by around, I guess it was 2007, 2008, Yahoo was using Hadoop to process what was the entire web at that point, when Yahoo still had a web search engine. And we'd taken the technology out of Nutch and christened it Hadoop. So that's sort of where things came out of. There are these two primary components, inspired both by Google papers. You've got HDFS, which is a distributed storage system. You take a lot of machines that are roughly similar to one another, with lots of hard drives attached to them, and you put them all together on a network and call it a file system, more or less. There's a little bit more to it, but not much. And on top of that, you have a computing layer, the MapReduce, which runs big batch computations over data sets that are living out in this file system. And it does so by moving the computation to the data, which I think Shai was talking about earlier, the importance of localizing the computation as much as possible. And that's very much the spirit here. So what we got out of it was something that scaled much more affordably than previous solutions. It was distributed, and if it's distributed, it's got to be reliable. Those things go hand in hand. And it offered a new style of use as well that was, I think, popularized here, which is rather than trying to, or forcing people to figure out what their schema was up front, and in a sense, think about what their queries were and what the problems they were to solve before they loaded their data. Rather, we encouraged a pattern where you load the data and then you figure out what you want to do with it. And you have this sort of more flexible architecture where you can experiment with it. So there was not just the sort of technological elements, there were also some stylistic elements in Hadoop. So since then, very rapidly, a bunch of other projects grew up around Hadoop, built on top of it. So Hadoop's sort of become a kernel for distributed computing. I think of it's very much analogous to an OS for distributed computing, where the kernel handles file systems and resource contention around processors, access controls, things like that. And then we get all these other layers that are built on top. Got HBase, I'll talk a bit more about. There's an online key value store, a NoSQL store, as they're called. Pig and Hive, which are scripting languages, which out of the back emit MapReduce jobs. Scoop, tool for moving data from a relational database into HDFS and back out. We've got Flume for if you've got events, say logs that you want to stream into HDFS or HBase and do so reliably. So real-time streaming. Uzi, workflow manager. You've got you want to have certain jobs and actions triggered by other things or on a regular basis, an hourly basis. Whir, if you want to deploy all this stuff in the cloud and Amazon, Rackspace, or whatnot. It's a set of scripts and so on to manage that. Mahout, machine learning library, and so on. And there's getting to be, I don't know, I've probably got 10 listed here, and there's probably 15 or 20 projects which are now generally bundled together into the Hadoop ecosystem. And they all share a pretty high degree of integration, which I think is really critical. So we started with this batch engine, MapReduce. It's a great tool. I mean, it's really, if you needed to analyze all of a data set and perform some computation over it, it's hard to beat. It gives, the ability to scale linearly is pretty unprecedented. There's not much else out there that can do that as well. It is just batch computation. There's a lot of other things that people might want to do besides batch. And so it formed this nice base for reuse, reused by Pig and Hive and so on. But also I think people pigeonhole Hadoop and say, well, it's just a batch computing system. If you want to do other stuff, you need a different system. But soon we saw HBase get added. This is inspired by another paper out of Google. Thanks, Google. The big table paper. And HBase, as I said, is a NoSQL store. So you've got you can do puts and gets under keys, key value pairs, and at a very high rate, and you see the results right as they happen. So it's definitely for sort of online computing. It's used, for example, who's a good example? Oh, well, Facebook uses HBase for every message. So it's used by online, by web systems, web-facing services frequently. But I think one of the things that helped HBase help propel it relative to other NoSQL stores is that it's integrated with this Hadoop platform, that it shares the storage, that you are, as much as possible, co-locating things. And you're sharing things like authentication and authorization and snapshots and disaster recovery and all these things. As much as possible, the operation of it is shared. And you also get some benefits where you can do a bulk load very effectively using MapReduce, or you can do a bulk analysis of an HBase table using MapReduce, because without necessarily having to move your data between two different systems. So it's a very popular combination. And I think it also indicates sort of the beginnings of where the platform is headed. Here we go. It shows us that big data isn't just batch computing. There's a lot of other, I think, themes that are the real things behind this. Scalability, I've mentioned several times. In order to scale, you need to be able to run on multiple computers. You need to be distributed. Once you're distributed, the reliability becomes critical. You can't have one without the other. If you've got one computer and it fails once a year, that might be fine. But if you've got 1,000 computers, you're going to have some failing every day, maybe more. You've got more network components involved as well. So you have to focus a lot on reliability. That's where the magic in all this is. Building a simple platform that's simple to program, but that does so reliably and spreads the computation and the data over all these resources. Another element that's a part of scalability is affordability. If you can do it on hardware that's 1/10 the cost, then you can afford to have 10 times the data. They really aren't different concepts, scalability and affordability. And similarly, the software needs to be affordable. And this is a case where open source is wonderful. The cost is effectively zero, at least to try it. Some people may want to get some support later, but I think that it also sets the basic level down quite low for the software. Also mentioned already the importance of this schema on read style, this notion of saving your data so that you can explore it. And last I want to mention this notion that having more data is oftentimes, not always, but oftentimes better than having a smarter algorithm. It gives you, in effect, a higher resolution picture of your business, whatever that may be, if you're collecting data. And in that, you can see more things, especially in sort of long tail problems. Talk about this more in a minute. So where do we want big data to go? So I like to have this concept of the Holy Grail. What we like to see. We obviously find open source to be a critical component. Running on inexpensive hardware is also a key. We want things to scale. We want all the systems, all the algorithms to scale linearly as far as possible, so that if you need to double the size, you can double the hardware. You need to have the latency, you can double the hardware. At least that's the ideal. There's also some other features which would be wonderful to have, which I think when we first set out down sort of the big data road, people didn't think were possible. They thought, if you're doing NoSQL, well, you need to give up joins. Just not gonna happen, and that's where we're gonna be. And transactions across multiple tables and things like that are also probably impossible in this world. But nonetheless, we might still like to have those. And so I've listed in here as things we like to get there. So how are we going to figure out where we're going and where we ought to go next? And quite fortunately, we've got these friends who live in the future, Google. Google has been doing this a little bit longer than the rest of the world, exploring this architectural space. And they sent us these messages from the future via these publications. We saw, in 2004, they published the GFS and MapReduce papers. In 2006, the Hadoop project was started. 2005, they talked about Sawzall. 2008, we saw Pig and Hive. 2006, I guess, Bigtable was published, and by 2008, there was HBase, directly based on it. More recently, there was a paper out of Google about a system called Dremel. Someone referred to it earlier today, I believe, for doing interactive SQL queries as opposed to batch SQL queries that Hive can do. And in 2012, Cloudera launched Impala, an open source SQL engine that solves a lot of these problems. It can do reasonably complex joins and give you interactive performance in SQL. Also last year, I think it's some very exciting work. Google talked about their work, a system called Spanner, where they showed how they can do transactions over a globally distributed database, which is it's just something I think we all thought wasn't going to happen anytime soon, and now we see it here. So it really begins to look like we can have this holy grail, and you think about, well, what is that system? It's a system that scales arbitrarily and supports all the features we've known, plus has a very general purpose platform that's very flexible. It starts to look like a very attractive platform for all kinds of computations. And I think we've got all kinds of problems that can benefit from this. As businesses collect more data and generate more data, they can optimize their businesses, find new businesses by taking advantage of this data. So a classic paper about this by some folks from Google, Peter Norvig notably gives a great talk on this about the unreasonable effectiveness of data. Encourage you to look on YouTube for that talk, where he talks about a number of cases where trying multiple algorithms and training them on data sets versus just training a simple algorithm on a larger data set works much better, gives you better results and with far less need to tweak things. And you've got something you can understand more easily. It's just, if you can afford to do it, it's in many cases a much better approach. Another interesting paper was a fellow from Walmart who was teaching a class at Stanford where he had students compete on a project. And he calls it more data usually beats better algorithms. In this case, he was talking about primarily not just the advantage of more data of the same type, but of combining data sets of different types. He was trying to solve this movie prediction problem. If you know that somebody's liked these movies, what movie will they like next? And notice that the students who combine data from, say, IMDb, so got other objective measures of movie quality with the predictions, then they achieved much better results. And again, this is something we see again and again, that it's not just about having more data, it's having more data from different sources. And we see in a lot of places, companies have their data siloed in different parts of the company and aren't able to easily combine it. And these kinds of systems can let you dump lots of different types of data together and begin to combine them in new ways and find new value. So overall, I really think it's important that these kinds of platforms support exploration. We don't know upfront all of the things we might want to do, but we need to save the data now, or else we won't have it in the future to analyze. We see a lot of customers who are taking data sets off of tape and restoring them and putting them online, not because they always know what they want to do with them, but just because they can, and now they can start to analyze and look at long-term trends. So instead of looking at the last months of transactions, this is, for example, credit card companies looking for fraud, they can now look at years of transactions and do one big analysis over that, over all that time. Hadoop is really growing to become a foundation for this kinds of things. It's becoming a very general purpose system that doesn't just support batch computation, but now interactive SQL. We recently saw the launch of a Solar running on Hadoop, very well integrated. Again, we'll share all of the backups, all of the data, all of the indexes and everything are in HDFS. It's not a parallel system at all. It's very much an integrated thing. Same authentication, same authorization. So you can do, this previous speaker was talking about importance of snapshots across all of your data. that will work with this. So it's becoming, as I said, an OS for big data. I want to close up with a little thought about how I've seen Hadoop get adopted. I think this pattern has occurred many times. I wasn't at Google when it started using GFS and MapReduce, but I've inferred pretty much that this is more or less the pattern that Google saw. They had a web search problem. They built some general purpose tools to help them better build their web index. And over time, they found that those tools became a foundation for all sorts of things in products outside of web search. I suspect that GFS and its follow-on file systems are now used much more widely outside of search than they are just in search at Google. Same with Yahoo. Yahoo started down this road trying to build a better search system, and now they don't even do search, yet they've got, 10, 20,000 nodes running Hadoop, maybe more than that nowadays. Doing log analysis, doing all sorts of predictions for their business. We see it at, as I mentioned, credit card companies, oil companies doing oil exploration, it's agricultural companies. It's across all industries. Folks are finding data sets that they can improve their businesses by better understanding. So they first find this big problem that demands this approach, which they can't either afford to do any other way, or they just can't get it to run any other way. They try it with Hadoop. They build a proof of concept. They find out it works, and they start to deploy it into production. And in the process, they start moving other data sets on. Other people in the organization start saying, hey, can I try something on that data? Can I load my data set? And pretty soon, it starts snowballing. And so it's really getting over that first hump, finding a business need where you can really demonstrate the value of building a cluster like this. And then after that, year over year, we see everyone continue to grow their adoption of these technologies. It's pretty exciting to see. So, not that many years ago, there were just a couple of us working on Hadoop. Now, there's thousands of folks using it. And I encourage you, if you're not already using this, to think about where it might be appropriate. Think about data that you have that you're ignoring, that's slipping through your fingers, and that you might be able to save and benefit from, and better see and understand what you're doing. Another thing is to think about the context of that information. Yahoo doesn't just save the simple sort of log line for each page view. It includes, it logs every single link and graphic on the page that wasn't clicked on, as well as the one that was clicked on, so that they can, in effect, reconstruct the page and figure out what someone might have read and passed over before they clicked on something, and do a much more thorough analysis. And they can afford to do this. It's inexpensive to store all that. Similarly, I know retailers who are looking at not just recording all of the products that are sold, but where they were shelved on the store when someone picked them up, and looking at that data and see if they can optimize the layouts of stores. And you can imagine there's a lot of more cases where it might be easy to grab some context about the data that you're storing and add that as well, and might have great value. So anyway, also think about data sets that you might, that people you know and work with might have that might complement your data set, and give you insights that you haven't imagined yet. So that's all I had for you today. Thank you very much for having me.